So excited. All right, guys, we got to review a little bit, and then we'll review with what we did yesterday. And you're going to see how this is a combination. Okay, friends, what's the first thing you look for when you factor? Greatest common factor. So sometimes you just need a common factor, but a lot of times we look for the greatest common factor. Okay, what's the common factor of 3x plus 6? 3. And so what would you have left? 3 times what? X plus 2. I mean, grueling, correct? Now, doesn't this look a little familiar? Maybe, maybe not. Let's look at the next one. Can I take out a common factor out of 1/2 x plus 3 halves? What did I hear? Yeah, you can take a 1/2 out of both. Basically, are we undistributed? We're really sitting there and we're dividing both terms by what value? 1/2, exactly. So we get here, x plus what? Is it 1/2, 3, 1, what is that? 1. What is this? What's 3 halves divided by 1/2? 2 over 1, it should be what? 3. So that'd be 1/2 plus 3. Now, why would I care about that? Well, let's think about this. Who can give me the standard form of the equation of a trig function? But it's Hannah, what do you got?
A sine b and in parentheses x plus or minus c parentheses and then plus or minus d.
And then we could replace that with cosine, tangent, whatever, right? That's going to be the standard form. Now, notice I said something should look kind of familiar. What's looking kind of familiar here? Are you starting to see a parentheses with something out front of it? Maybe we're going to be going there just a little bit. Okay, now, here's the thing. Now throw that out the window and still think mathematically. What would I do here if I say, all right, throw this out, and I still want you to factor out a number? If I factor out a number, I'm really what? Distributing something, correct? So here's my question. What if I, out of this algebraic expression here of 3x plus 2, what if I factor out a 3? What would I have left in my quantity? X plus what? How do I know if I'm right? Yeah, can't we just go ahead and just distribute it real quick and see if it gets right back to where we want it, right? So if I distribute it, well, 3 times x is 3x. 3 times 2/3 is 6/3. That's 3x plus 2. So did we factor the 3 out correctly? So notice, what number did I factor out? Did I factor out the 2 or did I factor out the 3? Okay, perfect. Okay. Next one. It says factor out 4. Who thinks they got this one for me? If I factor out a factor of 4 on this one. John, what do you got? 4 times x plus 1/4. Now, John, just because you answered, I'm taking on you guys, so please forgive me. Why do you know that's going to be a 1/4 inside the parentheses? Yeah, guys, if I'm taking a common factor out, what am I really saying I'm doing? I'm dividing everything by what? 4, which is really you're going 4x over 4 plus 1/4. Oh, what does my quantity get? X plus 1/4. Are you seeing how we like undistribute? Or you can even think like fractionally, like how are we getting those values? Because why do I need to know this? Oh, just so we can pull out our b value carefully. All right, here's one for you. Factor out 2/3. Do this with the person next to you and see if you guys get it right. Factor out 2/3. You can tell I did not write this because the fractions are slanted. It's driving me over the edge. think we got it? What do we get, guys? If I take out 2/3 out of this quantity, what do we get? X plus, what do we guys get? 3/4. Now, what's the one that's really easy to understand? Taking 2/3 away from x, is that not ultra easy? Because really you're thinking 2/3 x divided by 2/3. Oh, those go away to be 1. But what am I really doing to that 1/2? I'm dividing by 2/3, which means I'm really going 1/2 times what? 3/2, because remember, divide by a fraction is the same as multiplying by its reciprocal. And if I multiply my fractions across, that's going to be 3/4. All right. What about this one? 1/2 x plus 3/4. Factor out your 1/2 this time. What did you get? Or did you guys already do that one? Oh, no, good. There's a few of you right there. Guys, please don't work ahead. There's reasons why I'm doing what I'm doing, and I need you to stay with me. All right, if we factor out 1/2, what should we have left inside our parentheses? Should be x plus 3/2. How'd you guys do? And again, the ones that's not hard is, notice, every single one we factored out, we're just taking out the coefficient in front of the x variable, correct? I wonder, did we talk a little bit about this last week when we were practicing pulling out information in standard form? So friends, don't forget that you need to be really careful. Factoring something out is the same as dividing by that value. So 3/4 divided by 1/2. If you write it 3/4 times 2/1, oh yeah, that reduces down to 3/2. So you have to be good at doing this today, or your problems are going to be wrong. And besides, there's going to be a problem like this on your quiz tomorrow. Did everyone hear me on this? So make sure we understand with what we're doing. All right, here's the first example. It says, example 1, y equals a negative cosine times 1/3 x minus pi plus 1. So think of this like this, 1/3 x minus pi. Friends, can I graph this? This first equation right here, should I be able to graph this? The answer is what? No, because we graph only trig functions in what form? Yeah, exactly. So the reason why we practice this is we have to change to standard form. So if it's not in standard form, you have to get there first. And to do that, we use undistributing or factoring out the value. So when we look here, we're not going to do anything with that -1, are we? For standard form, do we need to do anything with that one? No. So we get a negative cosine, and then I look at this and I need a b value. I don't have a b value. Where can I get that b value very quickly? I heard it take out what? Right on. We're going to factor out the 1/3, which means, do I have to undistribute it from this binomial? Oh wait, weren't we just doing that the last 4 or 5 rows? Exactly. So when we look at, we divide out by 1/3, what do we get left inside our parentheses? X minus pi over 3, pi times 3, what is that? Shouldn't it be 3 pi? Shouldn't it be 3 pi on this one? And then we have our plus 1. Now someone goes, well, how did you get the 3 pi? What do I have to do to the negative pi? I have to divide it by what? 1/3. So it's negative pi times 3/1. Is that negative 3 pi? So understand, is there anyone stopping you from going off to the right to do a little bit of math? No. But now, do we have this in standard form? So the number one thing you need to ask tomorrow first is like, is this graph in standard form? If it's not in standard form, change it to the standard form, and then graph like normal. Make sense? That's how easy changing these are. Now that we've written it, and by the way, I'm going to look to see if you rewrote it, if you do it in standard form. What are going to be our values? And we're going to do the verbals of this very, very well. Guys, what's A? A is in -1, so what does that mean? Yep, flip over. We're going to do the verbals with this. X axis. Okay, what's B? We got 1/3. And then what is going to be the period this time? I got 2 pi divided by 1/3. That's what? 6 pi. Huh, I'm probably going to be playing with the scale on my graph here a little bit, so I don't have to worry about it too much. Guys, what is C? -3 pi. So that means we go shift right, 3 pi. Give me the verbals. What's D? 1. So we shift up what? Up 1. Guys, you think we can do this? No? Yeah? All right. How could we make this pretty simple for us to graph? I mean, I'm going to leave right here this to be 1 and -1. I'm going to let that be 0. But what would be a nice scale so I know for sure everything fits? Love construction. Yeah, I'd make every box a pi. Because is there anything wrong with doing that? No, as long as you mark your scale. So I would go here, this would be 3 pi, 4 pi, what's it, 1, 2, 3, 4, 5 pi, and then if you want to do the 6 pi, or you can even just go 3 pi and 6 pi, just anything that helps you mark this so you can quickly be able to get it done. All right, when we're graphing this, which two do we do together first? Yep, the period and our amplitude first. So we know that the period is 6 pi. So literally I'm going to go, oh, that's great. We have 6 pi. And then they say that our amplitude's a -1. So let's graph this real quick. Is this sine or cosine? Cosine. So where do we start? At the ends, right? And where are we at? We're at the -1 because a +1 times -1 is -1. So we have 1 here, we have 1 here, and then where do we go? Halfway, right? And where do we get that to be 3 pi? And then we go up or down? Now, out of curiosity, is that called a relative maximum or a relative minimum? Max, because it's up high, right? You guys with me on that? And then we go halfway. Half of the halves is what value? Say it louder, you guys got these answers in. Just say it out loud. They're what? The zeros. And remember, if they're not curved, I don't believe that you've done it or not. Okay, so we did the first two together, and then let's do the last two together. So graph these second. Taking the 5 points, you're going to shift right 3 pi. Now this time it's 3 boxes and you have 6 boxes, right? So make sure you're staying with your scale, and we go up 1. So we're going to shift right 3 pi, so we go 1, 2, 3, and then we go up 1. Shift 3, 1, 2, 3, and up 1. Shift right 3, 1, 2, 3, and up 1. Shift right 3, 1, 2, 3, and up 1, and then right 3, 1, 2, 3. Oops, I forgot my up 1. Let me go up 1. Guys, again, always check early to make sure I didn't do something crazy like go the wrong direction. But that would be your final graph. Is that really much harder than what we were doing yesterday? What do you think, Paul? Simple? Not bad, is it? All right, that's the whole point. This isn't hard, but friends, you may not graph without it being in what form first? Standard. Oh, thank you for listening. All right, you want to do the next one with your partner, or do you want me to do one more with you? Do it with your partner? All right, go for it with your partner. That works. Totally. Normally you two aren't stranded.
Yeah.
Guys, think easy scale for this. What would be an easy scale? What would be an easy scale to make this so your life is not hard? Alright, I'm watching some of you and you're not wrong. I just think you can make your lives easier than what you're doing. I would draw a different scale for most of you. It would have been a very easy problem for you if you would have thought this way. So let me give you an example. Guys, what is our rewritten function? Y equals what? A cosine 3/2 times x plus pi over 3 or 1/3 pi plus 1. Okay, so let's write down what we know. We have 1/2 here. How would we verbalize that, my friends? Vertical shrink, 1/2. Vertical shrink by a factor of what? A factor of 1/2, correct? All right, what's b this time? 3/2. But what are we looking for without even much thought? Period. So we got 2 pi over 3/2. Well, that ends up being 2 pi times 2/3, which is 4 pi thirds. I'm looking at that and I'm thinking my scale just went up by pi over 3. Because that's going to be a lot easier. I don't have to worry about am I giving it close enough type scenario on there. Okay, what's c value? Pi over 3, which means what? Shift left, pi over 3. All right, what's yours d this time? So we shift what? Up 1. All right, that's easy verbalization, easy for us to do. We put the first two together, and like I said, I would go up by thirds. So I know that 1 square, or 1 line, is a distance of pi thirds. And then we have our 0. Now, what would be another easy way of making this work well for us? What can we do for vertical scale? Could we go up by 1/2 this time? And make our lives really easy? Like, I know it seems like someone's like, is that cheating? Is it cheating? No. You change the scale to make your life easier in the long run. And guess what? I think, even though I make mistakes, I'm smart enough to follow your scale changes. As long as you do it right, it's right. Remember that. Sometimes there's more than one way to do a math problem correctly. And if you do it correctly, great. So in this case, I would have gone up there. Now, a whole bunch of you did it. Don't get me wrong. You will be fine. But I think it's just much easier doing it this way. Because then when we do our first two together, our period is over here at 4 pi over 3. So really, that's this right here. I have a perfect starting and an ending point now. And then we said that our vertical shrink by a factor of 1/2. Well, this is cosine again. So don't we start normally at 1? Instead of starting at 1, we start where? At 1/2. So we're here, we go halfway. We're at our negative 1/2, and then we do half of our halves. This was our initial graph. And then we just do our last one. I'm going to do this one in blue just because. We can sit there and we're going to go shift left pi over 3 and then up 1. Well, left pi over 3 is how many squares? That's just going to be 1 square left, right? So when I do that, I literally will go, okay, we go left pi over 3, which is 1 squared, up 1. Left, pi over 3, up 1. Left, pi over 3, up 1. Left, pi over 3, up 1. Doing the same thing. Now, those of you who kept the scale as normal, doesn't your graph still look like this, though? Yours is just what? Smaller. A little more narrow. The same thing happens. Are you guys with me on that? Especially if you mark your period spot correctly, even when you don't go to the same scale, you can easily get this correct. Because I was walking around, a lot of you were just marking 4 pi over 3. When, just remember, you have permission to change the scale. What if this ended up being over 4? What would you go up by? You can either stay at pi over 2, or you can even go like pi over 4. It just matters what the values are. Give yourself flexibility. Give yourself freedom. And make sure you bring an eraser for tomorrow. Right? When we're working good. Alright. Yes.
On the quiz, we have to write like for the shifts, like horizontal shift left.
What did I just tell you earlier in this period?
Like do we have to actually say the number? Or do
Yes.
we just say shift left?
Yes. You actually have to say the number, because otherwise shift left means nothing to me. The number has to go with it. Guys, this is the type of stuff. Notice I just put A, B, and C down, and then I describe what happens. Now someone goes, what if I don't have something like C or D? Just say what? None. Right? Or no horizontal shift, or no vertical shift. Yes, ma'am.
In the D, don't you do like 2 boxes?
Oh, you know what? I should have thought up 2. Oh, you know what we can do? Hold on. This is when, I wonder if I was selected if it'll let me move up 2. Sorry, I'm not going to let you have that on the, one night, but wow. Sometimes, good job. Paige, thank you for catching that. Guys, how many of you were sitting there thinking you should tell me that and didn't? Paige, you're my favorite today. You got the favorite status of all my classes today. All right, guys, you know me well enough to know. Aren't you supposed to stop me earlier than later? Don't smirk. There's always a smirking. So, okay, well, then we're on the same boat. But this is why I should not teach and talk at the same time. Like, I tell you, it's like my worst. All right, this is for you individually to do, and then compare with your partner. So try this next one on your own. These are actually really good practices. I'm liking these.
Same here.
Yes.
Does that still work? We put our middle two technically and then put parentheses. Is that
That would still work, as long as, but your distance of, yeah, this is still the same thing, because this would be pi over 3, that would still be pi. Yeah, yeah, the scale still works, totally. As long as it's like, I can tell what it is, it's perfect. Make sure you use the verbal, I wanna see the verbals.
reset my
And guys, on purpose for the quiz, I was working with Mr. Smith on it. On purpose, I did not put a set scale on there, so you guys can change scales to whatever you want, just like what we've been doing. I want it to be what works for your brain cells. First things first, did you get your change to non-standard form correctly? I just threw the non-standard form up there so you can double check yourself.
That's 2 pi over 1 half.
You should be doing it the way that I'm showing you. How many of you changed the horizontal scale from the normal pi over 2? And then do you make it like pi for every box?
Yeah.
Yeah. Yeah, you did that. I'm looking at you. I was doing it. You did. Yeah, like you just changed it. Like normally we say pi over 2, but like, yeah. All right. Guys, let's finish this one up real quick. What's A?
2.
Which means a what? Stretch by a factor of what? By a factor of 2. Okay, what's B? 1/2. But what we are looking for is the period. So 2 pi divided by 1/2. That's going to end up being 4 pi is our period. Okay, C is what? Negative 4 pi. So what do? Shift what? Shift right. Distance of 4 pi. And what's D, my friends? Yep, you just shift up 1. Okay, let's do the first together. We'll do those in blue. Scale with this one, I would leave normal scale for vertical, going up by 1. And then I would definitely change my scale here to be where I'm just working with it in terms of pi. Makes my life a lot easier knowing that we're going to be adding a 4 pi on. Otherwise, you have to go off the page, basically, off the graph. So with this one, let's mark our period. It's over here at 4 pi. It is sine this time. Where do we always start with sine? At the zeros at the end. So we're at 0, 0. Halfway is also 0. Half of the halves is, what's on my first next is going to be what? 2. And what's going to be our min? Notice I'm starting to use some terms back on you from good old Algebra 2 days, because we're going to ask you that type of stuff to write equations of trig functions. So this is our first graph so far, right? But then we need to do, and I'm going to do my final in red this time, I need to go right 4 pi, up 1. So in this case, that would be for me 4 boxes, or 4 squares to the right. So we go 1, 2, 3, 4, up 1, 1, 2, 3, 4, up 1, 1, 2, 3, 4, up 1, 1, 2, 3, 4, up 1. Paige, double check me. Am I on the right one this time? Did I go correct to scale? Did I? Okay, good. Thank you for catching that really right away. All right, and this would be your final graph. How are you guys feeling about graphing? Okay, let's practice the verbal stuff, because most of you are doing pretty good working with the scale and stuff, so that will be it for the